There's a lot of thoughts behind the background why we started doing these studies on shorter season corn and also shorter season soybeans. One of those is when I was serving in Clay County, there were professors in Lincoln saying, Jenny, what is going on? Why can't you get those growers to grow 3.0 and later soybean maturities? Why are they all growing these 2.4, 2.5s? And I just told them I can't argue with guys that are getting 80 bushel an acre soybean yields, planted in April, and using 2.4 maturities. But some other thoughts behind this are looking at, we were specifically asked to speak to the cover crop biomass. So if we're going with shorter season maturities, it provides a window for allowing for cover crops to follow that, perhaps getting more biomass. So that's the data that we're going to speak to. Also, if just different farmer systems, hitting different markets, spreading out harvest loads. So those are all the reasons behind this study. So we have some on-farm research data that we're going to share, as well as some additional studies that Chris and his team have done. So the first one, we're just going to talk just briefly on the corn side of it. And we have colleagues in the room that were involved with these studies. Basically, they were comparing 95-day versus 105, 111, and 115-day relative maturities. And as you can imagine, every year is different with the environmental conditions. So as we look at the data here, we've got two different sites. One site's up here, this is a different site down here. And I'm only going to focus on the yield. Again, you're looking at letters. The letters that are the same, so in this case, 105, 111, and 119, or 115 day, is saying that there's no difference in those yields, okay, for that particular site, that particular year. But it dropped off below the 105 day. That was a non-irrigated site. This is an irrigated site, and it also followed the same suit. 105, 111, 115 day, no yield difference here versus the 95 day. They continued the study in 2018. They added a 99-day relative maturity in there. So 95, 99, 105, 111, 114. And then this year, it was more typical of what we would anticipate, with longer season maturities getting higher yields. And in this case, it did separate statistically, where the 114-day yielded the best, 111 less than that. There's a difference here, and then the 99 and 95 were basically the same. So what we would say is basically, if you're going to look at shorter season hybrids for the focus of getting in there and drilling a cover crop for biomass production, we would say that you start losing too much yield, especially after 105 days. So 105 days would be kind of that window. Now let.
Yeah. Where is Gary still around, or did he take off? Oh, there's Gary. Do you remember anything you'd add to that, Gary? Because this was down in your neck of the woods. Between those 2 years, was there something that stood out to you? You recall?
2018. It was actually really dry that year. Really on a tight profile, and it got really dry. And surprisingly, did as well as it did. The longer season, they did better. And the ground was similar.
If I remember right, we'd have to go and dig a little. They might have planted earlier that second year, maybe, than the first year. Is that?
About the same, I think. It's real close.
On the long day, we had fall rain.
Sure.
Oh, that was the other thing, yeah.
Yeah, so I think part of it's catching rain at the right time, right, when that crop needs it. So this is actually this is almost a precursor to what Jenny just showed you. So this was done at one of our research sites down near Clay Center. So this is small plot work, and we were looking here a little bit wider range. We went from a 80-day hybrid again up to the 115-day hybrid. And this was tested at 2 planting dates. So we went mid-May on one of them, which is the black line, and then the dashed line, that was early June planting date. So we want to say, what's the effective planting date on these as well? And in this case, it was similar to that 2017 year, but in fact, we actually saw a little bit of a decrease in yield by the time we got all the way out there to that high end. And so on our early planted, our yields maximized at about 107 day, and we were, if I remember right, 230 bushel yields for the early planted stuff at 107 day. That was the best yield we had, and this is 2 years worth of data here summarized. And then for the late planted stuff, it was about 102 day is where we maximized our yield, and we were a little closer to 200 bushel on that one. So again, that trend kind of held over 2 years when we were testing it, and we wanted to see what happened on kind of the on-farm scale. 1 year it kind of held to what we saw. The next year it didn't follow it quite so close. But like Jenny mentioned, one of the reasons we were interested in this is we're looking for opportunities to establish cover crops. Because I'd say that's one of the bigger challenges is, you finish pulling corn out of the field and that window to do anything gets to be pretty short. So is there anything we could do to adjust that, give us an opportunity? And so this was one way we were thinking about it. So these are 2 years, again in Clay Center, looking at different planting dates of cover crops. And if you look at the green, this is the biomass of our rye cover crop in the spring. So you can see the earlier you plant, the more biomass you produce, right? So this kind of follows what you'd expect. But each of these planting dates, these are associated with different relative maturities that we harvested from the field. So we tried to get them as close as we could to the harvest dates of some of these different maturities. And so you can see at some point the yields didn't change, right? We saw that plateau in yield, but there was always a benefit in terms of harvest date, right? So the earlier the maturity group that you ran, the earlier you harvested, and that just gained us in terms of what we got for biomass. And so 2015, this was a great year for cover cropping. I don't know if any of you guys were doing it then, but if you remember back, we got 6,500 pounds of cover crop biomass planted October 2nd, and this was tested, or this was harvested on April 15th. So we sampled this really early, and we still had a little over 6,000 pounds early. Where the next year, 2016 into 17, we maxed out at about 2,000 pounds, but that same trend still existed, right? By the later we planted, the less we got. And so somewhere in here, we were looking for this tipping point. Is there a place at which we can back off the maturity group without impacting yield, but gain a little bit? And so right here, this is kind of that 105-day range on that maturity group. And so you can see that you do gain a little bit in terms of opportunity compared to those full season hybrids. And that's kind of what we were interested in seeing if that was possible. And then just to show visually, this is the difference here between a October 21st planting date versus October 2nd. This is April 15th the next year. And so you almost don't need to look at the data to say, we produce quite a bit more biomass just by planting about 2 weeks earlier that particular year. This was in 17, and this is actually following soybean, but it's the same idea. This is planted September 8th, September 22nd, October 9th, and then October 20th. And so the later we planted, it would affect how much biomass we were able to produce.
In that scow study, Chris, you guys harvested that on a timely manner regarding when it was mature. How did that compare with how you followed the drill with the cover crops?
Yeah, so we had a whole bunch of hybrids that we tested, and we couldn't get the drill out every time we harvested a hybrid. And so we just picked 4 or 6 planting dates, and we got as close as we could. And so we were probably within plus or minus, I'd say, a week of when each hybrid. And so there was a little bit of wiggle room in terms of what you could gain behind each of those hybrids, but we got as close as we could given what we were working with. Yep.
Okay, so that's the corn side. Now we're going to switch to the soybean side. And these first studies are on-farm research studies where we didn't look at the biomass. They were just looking at how did the yields compare to an early to mid-group 2 versus an early to mid-group 3. And so these are studies that were done in York and Seward counties. In 2018, we had 16 replications. 2019, we had 13 replications. So you can see in 2018 first, Seward site, we've got a group 2.4 versus a 3.5. Actually, one of the cooperators is in the room on that one. And then this other study, it's a 2.5 versus a 3.1 and 2.7 versus a 3.0. And all these were planted that first week of May. And when we combine the data site years together, what you can see, there's no statistical difference here between the group 2 and group 3s. I also took pods per plant and also node counts too. You're going to see it doesn't always correlate necessarily directly with the yield. And we also got to think about on the soybean yield component, one of those is seed size. And so seed size isn't factored in here. But basically that's showing there's no difference when you're looking at high yielding genetics within these different groups. Looking at 2019, Seward site, they were doing a Pioneer 2.1 versus a 3.1. In this case, the 2.1 was statistically significant in out-yielding the 3.1. This other Seward site looked at 4 different comparisons, and the group 2s out-yielded the group 3s in this particular location. And then there's no difference in the York site between those 2 numbers.
Yeah, so again, this was some research that's related to those couple of on-farm studies that Jenny showed. So we were looking again at different soybean varieties and how those yield across maturity groups. So I just show this to say, when we do small plot research, we can test a whole bunch of things in a small area and at least get some snapshot of what it's doing, but then it's nice to take that information and try to scale it up and see, does it still hold when you go on farm? So in this case, we ranged from a 0.3 maturity group soybean all the way to a 4.0. So we were able to test those extremes. You wouldn't necessarily want to test all that on farm because you know you're going to have some yield losses at the extreme ends. But it's nice to be able to see where are those edges. And so that's part of the reason we did this in small plots, is we could test that. And we also tested this at a number of different locations. So we had 4 locations in Nebraska that this study was done. But we also had a couple sites in Ohio and Kentucky for this particular study. And so I show this. This is showing the soybean yield across the maturity groups. And I just put this up here because I want you to glance at the trends here, right? So most of the study sites, they behave similarly. And if you zoom in and look at one site in particular, and what we saw is if you go from a maturity group 4 down to a 3, we didn't see any difference in yield. In fact, the yield plateaued or maximized in 1 year, 2017, at 67 bushels per acre at this site, and we maximized about 61 bushels in 2018. That was the highest yield we got, and that was at about a maturity group 3, and we didn't improve yields beyond that. And I thought it'd just be interesting to look. So if we go from a 3 down to a 2, what did that change in terms of our yield? So we went from 67 down to 63 by changing by 1 maturity group shorter 1 year, and 61 down to 58 the next year. And so just kind of keep that in mind here, and I'm going to show you another slide here that's interesting. So this is looking at the amount of time from when we planted till the soybeans reached R8. And we picked R8 just because that's a nice uniform time that we could evaluate between all of our treatments, because harvest time changes a lot by environment, by moisture of the soybean. So we said R8, at least that's a fixed point we can compare between treatments, and it'll give us an idea of approximately when you might be able to harvest. And so you can see that harvest date generally increased the later the maturity group. So the later maturity group, the later the harvest occurred. And so again, if you zoom in and look at one of our locations, if you go from a maturity group 4 down to a maturity group 3, the time to reach R8, or our hypothetical harvest, that was 10 to 13 days different. So we didn't lose anything in terms of yield, but we gained, say, about 10 days in terms of harvest time. If you go from a 3 down to a 2, well, you gain another 10 days. All right, so if you go from a 4 down to a 2, that's maybe 20 days you potentially could pick up, and then, at least for this particular study, that one site I was showing you, maybe 3 to 4 bushels from a 3 down to a 2. So do those 10 days gain you enough in terms of what you want to do with cover cropping to justify maybe 2 or 3 bushel difference? It depends on what you're doing and why you're doing it, right? But I think there's opportunity. And so at the end of the day, I think is trying to find where are these tipping points. So we have this difference in terms of yield versus time to harvest. I think what's interesting is where do those intersect, right? Is there a place at which yield, you don't necessarily gain any more in terms of yield, but you've shortened your harvest date as much as possible? And so is there kind of that tipping point? if you come back too far, you can always gain in terms of harvest time, and you get that window. But at some point, you're losing so much yield, it doesn't make any sense. So where's kind of that tipping point or that sweet spot? And I think that's what's been interesting about looking at some of these different studies is trying to identify some of those opportunities.
So basically, to wrap it all up, what we were seeing based on the data is that if you're looking at shorter season corn, you start losing too much yield as you go below around 105 relative maturity. But when it comes to beans, there's real opportunity there. If this is something that you're looking about doing after beans to increase cover crop biomass, depending on just looking at those genetics, which ones are the high yielding genetics in the 2.0 through 2.5, and you can gain possibly 10 extra days on getting your cover crop in.
Yep.